It's a pleasure to be here, and I'd like to start by thanking my sponsors, Sparks Children's Charity and the Medical Research Council, for funding my research. My background is I'm an ENT surgeon, so really I'm interested in the larynx, which is the voice box. And the voice box is important in this field because it really forms the interface between conventional transplantation and tissue engineering, which we've just heard about. And I'm going to share with you today some of the exciting work we're doing here at UCL with regards to tissue engineering of voice boxes. And I work with Professor Birchill, who's one of the great pioneers in the field, but sadly he can't be with us today because he's in the States. As surgeons, there are several options available to us when we're considering voice box transplantation. And I should stress that these are devastating conditions. We're talking about children that are born with lack of voice boxes, so they're unable to speak, they'll have swallowing problems, they may be fed into their stomach. We're also talking about adult patients as well, so these are patients that have, say, cancer of the voice box, or that their larynx has been injured in some way through previous operations or through trauma. A lot of work in the past has been done using autologous tissues, which we heard before was using the patient's own tissues, and the use of prosthetic materials, which is plastics, essentially. But when you're considering something like the voice box, which is as complex as it is, these don't work very well and they give very poor functional results. We've heard about allotransplantation today, so this is conventional organ transplantation, a bit like a heart, kidney, liver, and so on. But we've heard also about some of the problems with this. So patients will be on immunosuppressive drugs for the rest of their life with side effects and toxicity and the cost as well. And also the shortages in organ donors. So we need to start looking towards other options. And then finally, the area that I'm interested in is regenerative medicine. And this is creating new organs from scratch in the laboratory so that we have off-the-shelf products available for patients ready to be transplanted when they need them. In terms of the issues of laryngeal transplantation, there are, of course, several hurdles which need to be overcome. Of course, there's the ethics and the regulation, which we've heard about earlier. And we also have to bear in mind that when we're considering transplantation of a larynx, it's not like the kidney or the heart. This is essentially a quality of life operation, a bit like a face transplant. So when these patients are transplanted, you're swapping an improvement in quality of life, but on the downside, they're going to be on lifelong immunosuppressives for the rest of their life. And in the sort of field of larynx and face transplantation, that's a delicate trade-off. And really, the patients have to be carefully selected for this type of surgery. There's also the issue around the nerves. The nerves in the head and neck region behave rather strangely. They don't sort of wire up in the same way. And that's certainly an obstacle that we're spending a lot of time on, trying to overcome the problems with that. And we've already talked about the need for these lifelong, expensive drugs. A working party group has been set up at the Royal College of Surgeons of England, and this basically consists of experts within the field. And they've actually concluded that given the improvement in the quality of life, they have agreed for conventional laryngeal allotransplantation to take place in the UK, because up till now only 2 cases have been done, and they've both been in the US. But recently we've been given the green light to go ahead in the UK, which we're pleased about. In terms of the transplantation itself, it's basically taking the diseased one out and putting a new one in. This is a complex operation and it will take many hours, but it involves plumbing the new vessels in the neck, also bringing the nerves back together in the neck. These are the important delicate nerves that will control the voice box. And then there's various other things that need to go back in, like the thyroid gland and the parathyroid gland, which produce hormones. And then the windpipe needs to be connected at the bottom and at the top as well. So our team was involved in the second allotransplantation in the world, really. And this took place in collaboration between University College London and Peter Belaski at the University of California, Davis. And this took place in January 2011, last year. And really, we had an ideal candidate for this type of operation. Her name was Brenda Jensen, and you probably heard about her on the news. And she had several advantages, really. First of all, she had a totally scarred larynx, so she was not able to produce any voice whatsoever. So she was desperate to have the operation. That was the first thing. But secondly, and very importantly, she was already on immunosuppressive therapy because she had had a previous kidney and pancreas transplant in 2006. So she was the ideal patient for this type of operation. And that operation went ahead. Sadly, I don't have the video, but I've got the picture. And what we're looking at here, this is a camera put down through her nose, looking at the vocal cords, in fact, that produce voice. And actually, just 10 weeks after her surgery, she actually had movement of the vocal cords and had a remarkably good voice, and there was an improvement in swallowing. She still has a breathing tube in because the vocal cords haven't opened up as much as we'd like them to, and that goes back to what I was saying earlier about the nerves don't wire up as well in the head and neck as we'd like them to. But we hope with time we may be able to take the breathing tube out from her neck. And this is her at the press conference on January the 20th, 2011, and she said, "I don't know what the future may bring, but it will sure be better than what we've left behind." So she's really pleased with the outcome of the surgery and has no sort of hesitations for what she went through. Here at UCL, we're doing various work to try and get those nerves to work better. There's really three approaches we're using. One is to use other nerves within the region and to connect them up to try and get these vocal cords to move better. The second is to use various growth factors to try and stimulate the nerves to grow in the right way. And then the third thing we're doing is it's more an American group that we're working with, Zila in the United States. But he puts little pacemakers into the voice box itself. And what he does is he tries to stimulate the muscles of the voice box. So it's a bit like having a pacemaker in the heart, but this is in the voice box, and it electrically stimulates the muscles. But as I said at the beginning, the larynx, from our point of view, is an interface between the two, and we do have this problem of shortages of organs and the need for lifelong immunosuppression. So we are turning our head now to regenerative medicine, which has lots of attractive solutions. And this is Tony Atala, who's the director of the Wake Forest Institute of Regenerative Medicine, and they're really the pioneers in the field over in North Carolina. And he's a urologist by trade, and I think we heard earlier about his successes in the last talk with the bladder. So he's produced these bladders in the laboratory, and these have been transplanted into children that are born with debilitating conditions affecting their bladder, and they've had success. They've had a lot of success and have reported their findings in the Lancet. So, as I said, we're turning our attention towards this field. Chris Mason works here at UCL, at the UCL Centre for Stem Cells and Regenerative Medicine, and helped to set up the London Regenerative Medicine Network. And he's defined regenerative medicine as the use of cells and tissues to really restore or replace function, which we saw earlier, using cells, scaffolds, or a combination of the two. And we're interested in tissue engineering larynxes or voice boxes, and this is what it looks like. So this is a larynx. It's actually a pig larynx, not a human larynx, but it's a pig larynx that has been decellularized. That means it's been stripped of all the cells, which we heard about in the last talk. So it's a bit like putting fairy liquid on the tissue to take all the cells away, because we want to get rid of the cells, because otherwise they will be rejected when we transplant this into our patient. And then we put stem cells on. So this is what the larynx looks like before it's going to be transplanted in, with the stem cells already coated. And there you can see the vocal cords. And this work is done in collaboration with the Northwick Park Institute for Medical Research. We're also looking at other organs. So we're looking at, say, the esophagus, for example. Children that are born with atresia of the esophagus, where they're not able to swallow properly. Again, debilitating conditions. The diaphragm as well. Kids that are born with congenital diaphragmatic hernias, that has a 50% mortality. So again, there's a clinical need for replacement tissue. And also intestine that we heard about earlier, both for children that have this problem of short bowel syndrome, where they're not able to get enough nutrients and it can be fatal, but also adults that have various conditions that cause shortages in bowel that require them to be fed into the blood, if you like, and that has serious risks in its own right. So we've had success down with palliodocopy at the Institute of Child Health, and this is what a tissue-engineered intestine looks like. This is actually in a rat, but it's a proof of principle, and it shows that if we can do this in a rat, we hope in the next few years we'll be able to translate this into humans. So I'd like to conclude with a quote by Christopher Reeve, or Superman, as you probably know him. He helped to set up the California Institute of Regenerative Medicine, which again is sort of a leading centre in the world for regenerative medicine. And he actually donated a lot of money towards the sort of network, if you like. But sadly, he died just before he could see the finished product. But this was his quote in his last few weeks, really. He said, so many of our dreams at first seem impossible, then they seem improbable, and then, when we summon the will, they soon become inevitable. So I think in tissue engineering, we're probably at the improbable stage, but we hope that with time and with more patience, we'll be able to get to the inevitable stage so that this becomes a frequent practice in the NHS. Thank you very much.